Portal is a beloved series made by Valve. Released for the home computers in 2007, Portal is an immediate success, not only revolutionizing the world of modern puzzle video games, but the entire industry of digital games as a whole. The story of a test subject forced into experiments by a rogue artificial intelligence, mixed with the gradually complex levels of puzzles, became the selling point of the Portal series. But Portal would never be the game it is today, if not for its famous game mechanics. The concept of portals have been an integral part of storytelling. Portals have been used numerous times in both science fiction and fantasy stories as a method of shortcut in traveling from one point to another. As of right now, portals are just that, fictional concepts that evolve with each interpretation. Some may say portals are shortcuts, or others may see them as methods of hopping through dimensions or realms. Each version of a portal depends on your artist or authors. Portal is no different, bringing in a fresh new take on the concept using aspects of science fiction and real-life physics to create a definitive take on portals. With our ever-expanding knowledge of the universe, are we able to figure out what portals in the Portal video games are, and if so, is it possible to create them in real life? Well, let's find out. Before we dive deep on how portals could hypothetically exist in real life, it's probably best if I explain to you the game mechanics. You see, in Portal, there is this object called the portal gun that shoots out two different kinds of portals, an orange and a blue portal. These portals can only be placed on a specific material, a white-colored wall. I'll go back to this topic later on. One of the most important points to keep in mind is that any object that passes through either portal will maintain its velocity when coming out on the other side, regardless of position or orientation. For example, you see this big gap here? I have to get from that point all the way to that door there. I can't just simply portal to the door since there are no white walls. I also can't jump from that ledge since I don't have enough momentum. So what do? There is a white surface down that elevator shaft down there. I can put a portal there and another on the ledge. Then I can jump into the portal from up here and out the other side so I can make the jump. Now, there are numerous hypotheses on how the portal guns work. We don't have a real-life counterpart of the portal guns, so we'll have to rely on known physics and create hypotheses to explain these portals as closely to reality as possible. There are many known theories on how portal guns work. I will only pick two of the most well-known. Each of these theories will be explained in detail. I will elaborate on how they could work, and if possible, I will debunk them. We also need to set a certain criteria so we can choose which of these theories are the closest to reality. First of all, the theory must abide as many known physical boundaries as possible. Second, it must be the most feasible and the one making most sense to work with our current technology so that we can replicate it in real life or be able to do so in the near future. Third, we will compare these theories in answering Portal's well-known paradoxes. But what is the Portal paradox? Some of you may not be too familiar with them. These paradoxes are well known in the gaming community and have even gained interest from the fields of professional physicists and scientists alike. This is how the paradox goes. First, imagine a platform and a ceiling, with the ceiling slowly moving towards the platform. Done? Now, we put a portal on the ceiling facing the platform and a different portal on another platform. Then, we put an object on the platform. Let's say a cube. Now the question is, as the cube shoots out the second portal, would the cube be stationary or would it shoot out at the speed of the first portal? This is the Portal paradox. Amongst the theories that I will be presenting to you today, the most popular one is perhaps the theory that portals are actually wormholes. Wormholes are essentially shortcuts utilizing the flexibility of space and time. This theory was most widely accepted, and if you try to search online or ask people how portals work, this is the answer that they will most likely give you. Of course, people believe this theory for a reason. Wormholes are the simplest explanation to the portals in Portal mystery. They are essentially shortcuts from one location in the universe to another, exactly how they work in the Portal games. They are a shortcut from 2 points inside the game, so you can go from one point to another and reach it quickly. The speed that the first portal is in would be the speed that the object would be as it shoots out the second portal. This is exactly why the theory is widely accepted, and people generally agree to this hypothesis. However, there are a couple of known flaws to this theory. First is that wormholes are very small, like quark-size small. To enlarge a wormhole, we need dark matter, and harnessing dark matter may be possible in the future, so no problem with that, right? That would be the case if not for the second issue. Objects on the Earth move at speed relative to Earth's, which is around 1,000 kilometers per hour. Wormholes, on the other hand, move relative to the speed of space-time, which means that even if a wormhole is to be utilized, it would disappear so fast because the Earth's movement, which is relative to the Sun's movement, is way quicker than the wormholes. So, is it possible for us to create a portal device? Are we truly hopeless? Well, not really. Let me introduce you to the second hypothesis, quantum tunneling. Not only is this the most feasible solution to portals, but it is even approved by the developers of the game themselves. As the name suggests, quantum tunneling is based on quantum physics. You see, the world of quantum physics is ruled by probability. If it is possible for a certain condition to occur, no matter how small the chance of it actually occurring is, we still consider it as an absolute certainty. Let me elaborate on the concept of quantum tunneling. You see this ball? On the other side of that valley is a steeper slope. Now, normally, the only way that the ball can pass through is by going up that hill. This is the classical route. But quantum mechanics offer a different solution. Since the ball really wants to get to that steep slope, the ball will use any means necessary to get there, even if it has to go through the hill. Since this is a possibility, then quantum mechanics sets this as a real method for the ball to get to the slope. This is the quantum route. Keep this analogy in mind as I proceed with the explanation. A very important law in quantum physics states that a particle's location remains unknown until it is observed. Until then, they are described using the term wave function. Now, imagine that the barrier is thin and has less energy than the wave function. The amplitude of the wave function will still decay inside the barrier. However, the wave function does not reach an amplitude of 0 inside the barrier, which means that the function can still exit through the other side. On each side of the barrier, a portion of the wave passes through and another portion reflects. If the wave function can pass through, so can the particle. The thinner the barrier, the larger chance of the particle to pass through. But how do we go from quantum-sized particles to the scale of the ball? We will need a lot of energy to do such things. Luckily enough, this is something that the portal guns from Portal have already solved for us. One of the key components of the portal gun is a black hole and a black hole cooling fan. But the black hole is not used to make wormholes, it is used as a battery. Here's a fun fact for you, black holes are the most efficient power source in the universe. If we take two conductive metals and flow an electrical current through them, the electrons will flow from one metal to the other, unless there's a barrier. There's the special state of metal called the superconducting state. In this state, lightly bound fermions open up energy levels, which allows a greater probability for electrons to tunnel through the barrier. Let's try making a superconductive metal. First, of course, we need two metals. I choose aluminum and lead. Now we make each of these metals very thin, around 1800 to 2500 angstroms thin. We leave the aluminum to oxidize so the oxygen can become our barrier. Then we put two components together. Then we freeze them steadily. To oversimplify what's happening, as the temperature decreases, the fermions open up energy levels and allow a greater chance for the electrons to tunnel. So, as it gets colder, more electrons can tunnel through. Now, as previously stated, portals can only be placed on white materials. Said material is made of ground-up moon dust, which just so happen to contain both aluminum and lead. This means that when the first portal is placed, it starts a link for quantum tunnels and then connects to another surface using the second portal. The only question left to answer is, how does this theory answer the portal paradox? Well, in quantum tunneling, if one of the surfaces move, the chances of the particles to pass through the barrier is decreased exponentially. Thus, if one of the surfaces starts to move, the portal would simply cease to exist. Well, there it is, folks. This may not be the only possible solution to creating a portals in real life, but it certainly is the most feasible at the moment. So why aren't we making portal guns yet? Well, unless we found a way to harness energy from a black hole, it's practically almost impossible to create a portal gun now. But hopefully we can do so in the foreseeable future. But for now, remember, it's all just a theory. A game theory. Thanks for watching.